Okay, we good with this? I do want to mention something about this. I don't want to get in the way of anybody still trying to write. And it's really small print. But this is giving us a unit that you may have never seen before, and I think that we might as well talk about it while it's on the screen. There is a unit, when you're talking about sizes of atoms, I mean atoms are really, really small, as you know. And so the unit for the diameter of an atom, for instance, or the size of its nucleus, would be measured in this symbol right here. You know what that is? It's angstroms. Right, angstroms. An angstrom is a 10 to the negative 10th meter. 10 to the negative 10th. It would be a tenth of a nanometer. And just, I mention it just because it's on there, and if you ever run into it, you'll know what an angstrom is. It is a metric unit. They kind of deviated from the typical metric prefixes for that special unit, the angstrom. So you can see, these are all the alkali metals, and so the neutral alkali metals, as you would guess, are getting bigger as we go down. And of course the ions get bigger too, but I mean as we go down. When lithium loses one electron, now lithium is very simple. It's got 3 protons in the nucleus, 3 protons, positively charged. It's got 3 electrons when it's neutral, but when it loses one of its electrons, now it's got 3 protons in the nucleus, only responsible for holding 2 electrons around it. So the protons kind of win, and that draws the remaining electrons much more close. So when you have an imbalance where you have more protons than electrons, that draws the electrons always very close in. And again, it's a noticeable change. It's not just a subtle change, it's a pretty big time change. You can even see a bigger change when we look at how the size changes for a negative ion. Fluorine, when it's neutral, is a cute little thing, 0.64 angstroms. It doubles in size in its radius when it goes from neutral to negative 1. So now we have fluorine. In that nucleus, there's 9 protons. Over here in the nucleus, there's still 9 protons. But now the 9 protons over here are responsible for holding 10 electrons. Now this time the electrons are kind of winning. And the 9 protons aren't as effective at holding 10 electrons. So it's going to get bigger. So on the next slide, this I think is taken out of the book, where we're going to have to compare the size of different things. And some of these are pretty obvious, and some of them are not so obvious. What would be a larger radius, magnesium ion or Mg plus 2?
Mg.
The neutral Mg, right? Yeah, because when the magnesium forms a positive field, loses 2 of its electrons, it gets real small. So just for a comparison's sake, you've got magnesium, 12 protons, and that's holding 12 electrons. That's neutral magnesium. But when you have magnesium ion, when it's lost 2, it's going to be like this. 12 protons, same exact nucleus, but now, whoop, only 10 electrons. So now that imbalance of proton in favor of the protons draws those remaining electrons in real tight. So yeah, this one is the larger radius. Yep. Between calcium and nitrogen. Calcium and the sodium ion. Who's bigger?
Calcium.
Yeah, the calcium is definitely going to be bigger. The sodium, when it becomes a positive 1 ion, it gets real small. Calcium, is on the left side of the periodic table.
Ah! Shoot. Sorry.
Did the video stop automatically?
I froze.
Calcium is very big, and sodium would be big too because it's on the left, but when it forms a positive ion, it gets way smaller. So, yeah, but calcium is going to be the bigger one in that case. The chlorine ion versus bromide, this one is so easy. The bromide is, yeah, both of them form a -1, which means both of them get bigger than the neutral atom, but bromide being farther down has 1 more energy level of electrons, it's bigger. How about this one? Now I want you to think carefully about this one. In fact, I would ask you, if you think you know which one is bigger, try to think about why, and I want to call on you. It's the fluoride ion, F -1, and O negative 2. So two ions, which one would be a bigger radius and why?
What? Oh. I don't like phone with me
We have this.
She's awake.
For now. Come on, who's got this? Fluoride oxide. Matthew.
Me and Big Cash are saying, oh, because,
Only Big Cash said this, right?
O starts off bigger, so,
Nope.
dang it.
Yes, yes, it does. It does start bigger, yeah.
Yeah.
Because they get smaller as we go to the right.
Does it like X?
More to it. Yeah. How many electrons does F negative 1 have?
Electrons?
Yes, how many electrons does F when it has a negative 1 ion?
That's not good.
It's got 10. Yeah. It's got 9 when it's neutral, so it has a negative 1, gains 1 electron, it's got 10. How many electrons does O negative 2 have?
Oh.
They both have the same number of electrons, but fluorine has 9 protons responsible for holding 10 electrons. Oxygen only has 8 protons responsible for holding 10. So fluorine, when it makes fluoride, you got 9 protons, and that's going to get much bigger, holding 10 electrons. Before, fluorine was really as small, but gaining an electron, out it goes. The oxide ion now only has 8 protons. By comparison, it's going to get bigger because the more electrons versus protons that you have, like this has an imbalance, 10 electrons to 8 protons. Oh man, the electrons are definitely winning. Out it goes. It's a bigger radius. So you were right, but I was hoping that you'd say because oxygen doesn't have as many protons. Are we okay with that? Magnesium ion, chloride ion. They're in the same row. Magnesium's on the left and chloride's on the right. You know, if they're neutral, magnesium is much bigger because they get smaller as we go to the right. What about if they form ions, though?
Chlorine.
You didn't circle the O.
Yeah.
Thank you. Yeah. It's the chloride ion. Because the magnesium ion is going to be, I already did the magnesium ion, it's like that. It gets real compact. You get 12 protons only hanging on to 10 electrons. That's going to be a very small ion. And so you got, like that. Chlorine, when it's neutral, remember, it's real small, but now it's got 17 protons holding on to 18 electrons. It's not as effective as hanging on to 18 electrons as it was to 17. So just know, like it said on the previous slide, as an atom gains electrons, now it's got more electrons than protons, it's going to kind of balloon out, whereas positives are going to get smaller. Anybody have any questions about that? Emily?
What if it's like Rb plus and Cl minus?
Rb plus and Cl minus. You see Rb, number 37? I think that you can answer this one with confidence. What would you say?
Rb plus.
Bigger? No, I disagree.
So, okay, in general, the negative ion is always bigger.
I would say so, yeah. They're 2 energy levels away from each other. Chlorine ends the 3p, and rubidium is starting the 5s. Yeah, rubidium is going to get smaller. Chlorine is going to get noticeably bigger. I would vote for the chloride ion being bigger than rubidium. Yep.
It's like is on another energy level, so it's like.
Yeah, I mean you do have that extra energy level of electrons, which would naturally make the rubidium bigger. But when they're ions, yeah. And fortunately, I would never ask you that. There's not a chance you would ever be asked that on any exam without having the values for it. Yep. Anything else about this? All right. Well, I wanted to stop early enough today because if you have any questions about homework problems or anything, this would be a great time to ask. And of course, tomorrow's a quiz day, so you can ask tomorrow too. But you've been working on them. I would want to say that there's 2 questions in there that I'm not excited about. One of the questions was the Heisenberg uncertainty principle, where you had to use the equation that Heisenberg gave. I don't really see the point in that. Number 69, just cross it off. Don't do it.
Don't question.
Was Heisenberg the Nazi?
69.
That's the one.
That's why.
Yep. That's not why I crossed it off.
Oh, you wanna cut video?
Well, no, I think that people watching the video should know this too. Also, number 84. I think it's 84. Did you have a question about 84?
I was going to ask you.
Yep. That was the exceptional electron configurations. We did not talk about that. It has something to do with the half-filled rule. We didn't do that one, and I am going to just ignore exceptional electron configurations. Just learn them the way that we learned them and not have anything weird. Okay? So skip 69, skip 84, and I think everything else is fair game. One of the questions, or 2 of the questions, are about the Debroglie wavelength. They ask you about an electron in one of them and a neutron in one of them. In the front inside cover of your book, they give you the mass of an electron and the mass of a neutron. Use that. It doesn't really indicate anywhere else. Sir Johnny?
Values are you giving us for this? Like,
I'll give you the Bohr equation, the negative 2.178 number. I'll give you that. And the h and the c, the speed of light. I think that's it.
I think the electron.
Yes?
The chloride ion is bigger by 1.
For
We were talking about which one. I'm trying to think of who was right then. So you said rubidium, right?
yeah.
Because it was more energy levels? Yep. The seasoned old chemist got you on that. Really by luck. You said it's 1 picometer. Something like that. Don, you going to close this out?
Alright guys, it's the end of the vlog. Don't forget to subscribe, like, turn that bell notification on, and don't forget to donate to Mr. Moore.
Just our class. They can do
People are
it.
going to donate to me?
People will donate.
Oh.
You asked, they will donate.
Excellent.
Guys, who's gonna open the
PayPal, that would
who's
be
gonna
great.